evening friends, and in this video we are going to learn about how to find the determinants of a matrix. So the idea should be very clear. I'm just talking about determinant of a matrix. So suppose we have a matrix A represented by, so I take with small values. First like square matrix. So 2, 7, minus 1, 4. So the determinant of this matrix is simply, we represent this as A into parallel brackets or bars, or you can also write that A. There is no problem with that. And then you have to find this. If you represent this matrix as determinants, you don't need to make it brackets, only you need to make these two parallel bars. And this is 2, 7, minus 1, 4. So if you just find, this is the product of the elements corresponding to the principal diagonals 4 and 2. So this is 8 minus 1, 7 is minus 7. So 8 plus 7 is 15. So this is called the determinant of a square matrix, and this matrix is of the order 2 by 2. But when you have a matrix of other order like 3 or 4, then the case becomes a little complicated. So let me clear this part of screen and I'll take another example where we'll discuss how to find the determinant of a 3. So now I take any random matrix A with the element 2, minus 1, 4, 0, 1, 3 and 1, 2, minus 1. Now we have to find the determinant of a matrix, so det A. Then how do we find? First you take any first row or column, whatever. So first I say, suppose if I take this one, this is my target row. So 2, so 2 is the element multiplied with the minor value of the determinant of this element. Means if you just cover this, then what you get? This one. So 2 and then 1, 3, 2 minus 1. Okay. So what you are getting, 2 this into the minor of this matrix. And then for second one, if I just consider the sign also, so this will become 2 this into cofactor of itself, that is this. And then for this one, this into the cofactors of the corresponding this element. So we have minus 1. And if you find the cofactor, because this is coming to first row, second column, so sum of these two is odd, so it will become negative. So we write plus 1, and then if you cover these two, so what do you get? 0, 1, 3 minus 1. 0, 1, 3 minus 1. Sorry, this is not matrix, this is determinant, plus this fourth one, so 4. And then we have, if you cover this 4 here, then what you get? 0, 1, 1, 2. 0, 1, 1, 2. So now I find the value. So this is 2 times, same thing, this into this, minus this into this. So the minus 1, minus 6, plus 1, this is 0, minus 3, plus 4, this is 0, minus 1. So this is minus 7 and 2 is minus 14, minus 3 and minus 4. So we are getting the value as minus. Now pay attention to this explanation again. So if you see that, what is the representation or position subscript for this element is A11 and this is A13. So we have A12, A13. Now I am trying to find out the cofactor of 2. So cofactor of A11, and what is cofactor of A11? this is minus 1 to the power this 1 plus 1 2 into minor of A11. So the minor of A11, sorry, this is A12 I have written, this is A11. So the minor of A11, and how to find the minor of A11? Same way, just cover the element belonging, cover the row, entire row and entire column of the element. So this element belongs to the first row and first column. So I cover this first row and the first column. So what I'm getting, this square smaller matrix of order 2 by 2, this is 1 3 2 minus 1, 1 3 2 minus 1. Now what is the determinant value of this? Minus 1 into 1 minus 1 minus 6 minus 6. So the value of this element is minus 6, and then this is minus 1 minus 6 minus 6. And if you write the minus 1 to the power, the sum of the scripts, this 1 1, so this is even number, so it will be just minus 6. And wait, I think, yes, so sorry, this is minus 1 minus 6, it should be minus 7, yes. So now minus 7 and multiplied with this 2 means this, you can say that this value, first one, is A11 into cofactors of 1 1, means 1 1 is 2 and the cofactors of 1 1 is minus 7. So 2 multiplied with minus 7 will be minus 14. Now I find the same thing, the cofactors of 1 2. So A12 is this value, because if you cover this row and this column, so you are getting 0 1 3 minus 1 0 1 3 minus 1. This is value is 0 minus 3 is minus 3, this one, and multiplied with 1, so this is minus 3, so minus 3. And then A11 A12, sorry, this should be 1 2, this is also 1 2, this is 1 3 C13, and then C13 means cover this one. So what you're getting, this part, that is this. So 2 zeros are 0, minus 1 is minus 1, and element value is 4. So 4 into, but this is again 1 plus 3 even, so no sign change. 1 plus 2 odd, so sign should be changed. So this I have done, and here this is the way. It means I am finding the product of the sum of the elements corresponding to their cofactors. Now if I try to do the same thing here for this one, then I have 2. So if I cover this row and this one, so I get again this very same thing, minus 1 and minus 6 is minus 7. Then I go for this is 0, does not make any difference, so forget it, this is 1. But this is the third element, this would be minus, and then it is 1, and then this is gone and this is gone, so you are getting this one, minus 3 minus 4 is minus 7, minus 3 minus 4 is minus 7, and then you multiply and you are getting minus 14 plus 7, again you are getting something like minus 7. So this is 2 minus 1, 2 minus 7, 2, and then minus 1 minus 6, minus 7 to minus 14, then it is minus 1, this will become plus 1, this is gone, 0, minus 3, yes, and then this is 4 times, this is 0 minus 1, so this is minus 4. So I think this is going pretty clear, and then I take another example in the next video, and then I'll explain with the help of some example. Now friends, we are going to understand about the applicability of matrices in our day-to-day life. So a layman doesn't have definitely any role of the matrices. If he can spend his entire life without knowing matrices, there's no problem with that. But if you are into the field of mathematics, and if you want to go into the field of engineering or the higher studies, then the matrices are very, very important, because they help you solve the equations. So here I have taken one equation, 3 equations are there, and they have 3 variables, so we need to solve them simultaneously. The existing way of solving these equations are thus: we find the value of z in terms of x, and then I put those values in these two equations. Then slowly the given set of three equations with the three variables x, y and z will become two equations with the two variables x and y only, and then you can solve them simultaneously to find their answers. But here we are not going to do that tedious method, and we are going directly to solve them using the idea and concept of matrix. So if you say that this matrix can be represented as AX equals B. Now A, what is A? A is the matrix formed by the coefficients of these variables. So I write A is, so 1, 2, 1, 1, 2, 1. And here see, you have x and z, no y. It means you can take it as 0y. So 1, 0, 3. 1, 0, 3. Then you have x and y but no z. So you can write 0z. So 2 minus 3 and 0. 2 minus 3 and 0. Then what is x? X is these values x, y, z. And what is the value of the product of these two will be the 7, 11 and 1. 7, 11 and 1. If you multiply this with this, you will get this equation compared with 7. Second row, this column, this. So this representation of equations, three equations, can be represented like this, AX as B. Now, if I just multiply this by its inverse, so if I write AX, A inverse is, or pre-multiply means I write A inverse first, that will be better. So A inverse AX as A inverse B. So you know that A inverse A will become identity matrix I, X, and this becomes A inverse B. Now the identity matrix into any matrix will be that matrix itself. So I multiplied with X will be just X, and you will have A inverse B. Means if you find A inverse B, A inverse and multiply it with B, like you find A inverse and then multiply it with B, then this one will give you a matrix of the very same nature, and then by comparing the corresponding coefficients, because this equal sign says that x should be compared because x has to be of the same order, then x can be compared as the product of A inverse and B. So now we are going to solve them. First what I need to find A inverse. So what I do that, first I need to check whether A inverse is possible or not. Then how will you do that? You can simply find the determinant value of A. Like if det A is not equal to 0, like if determinant of A is a non-zero value, then its inverse is possible. So first I find the det value. So here I find det. So det A is simple determinant form representation of the same matrix. So it is 1, 2, 1, 1, 0, 3, 2, minus 3, 0. Then I go for this 1, and then you can cover this and cover this. So find the value of this. 0 into 0 minus, so 0 minus 9, that is plus 9. Then you, for second element, this is negative because its position is 1, 2, and sum of 1 plus 2 on the power of minus 1 is odd, so it's negative. So minus 2. Now this is gone, you are getting this. So 0 into 1 is 0, and this is minus 6. So this is minus 6 plus the third one, 1, and then this is gone, that particular row is gone, this particular column is gone. So minus 3 only. So determinant value is 9 plus 12 minus 3. So 12 minus 3 is 9, 9 plus 9 is 18. So the determinant value we are getting it as 18. Now I need to clear some part of the screen, but you keep this in your head. This is our matrix and its determinant value is 18. So now what I have to find, that I have to find the matrix of cofactors of A. So I write matrix of cofactors of A. So what I do that, I simply write a matrix and then I'll go a little faster for this particular element number 1. So this is covered and then this is covered. So what I get? 0 into 0 minus 3. So 0 minus 9 is 9. Now I go for second element. So the second element and covered with this, what are you getting? 0 into 1 minus 3 into 2 is 6. So 0 minus 6 is minus 6. Now I go for the third element. So it goes like this. So what you are seeing, this small matrix is minus 3, 1, minus 3. Then I go for second row, first element, this element. Then you are getting 0 minus 3, that is 3. Then for second element, this is 0 minus 2, minus 2. Then for third element, this is minus 3, minus 4, minus 7. Then for first element, 6 minus 0, 6. For the second element, 3 minus 1, 2. For last element 0, this is 0 minus 2, that is minus 2. Now I change the sign because if you pay attention, the sign changes alternatively because 1, 1 is even, odd, even, odd, even, odd. So you can say even, odd. Positioning I am saying 1, 1 is even, 1, 2, odd. So even, odd, even, odd, even, odd, even, odd, even. Where you have odd, you have to change the sign. So unchanged, like positive, negative, positive, negative, positive, negative, positive, negative. So you can say in the case of 3 by 3, it just gives you a pattern that alternatively the second element will be negative. So this one will be negative. So already minus 6 become plus 6. No change, negative. No change, change. No change, change. So this is the matrix of cofactors of A with the proper value sign. Now we have to find transpose of this, and that is called as adjoint of A. So this is adjoint of A is transpose of matrix of cofactors of A. That is 9, 6 minus 3. So 9, 6 minus 3 will become 9, 6 minus 3. Minus 3 minus 2, 7. Minus 3 minus 2, 7. And then 6 minus 2 minus 2. 6 minus 2 minus 2. This is called adjoint of A. And now the final term, A inverse. What is A inverse? A inverse is 1 over determinant A into adjoint of A. So what is 1 over 18? And then I have little space here. So I'll just squeeze the elements. So this is 9 minus 3, 6. 9 minus 3, 6. 6 minus 2 minus 2. 6 minus 2 minus 2. And then minus 3, 7 minus 2. Minus 3, 7 minus 2. So this is your A inverse. Now what we have to do, because here you saw that X was A inverse B. So what is A inverse? This is my A inverse. What is B? This is my B. 7 and minus 11. And then the resultant of this will be of this matrix XYZ. So I remove some part of this so that with the minimal work I can get. Here I write A inverse B. This is my B and this is my X and this is A inverse. So B is 7, 11, 1. And this is my X, which is X, Y, Z, like this. Now this part I don't need anymore. So gone. Now I need to multiply. And if I am wrong, if I have made some mistake, then very frankly I'm saying it's very difficult to debug because most of the part I've already omitted. Okay, so now hopefully I should not be wrong. Let's see. So this is 1 over 18. Now this row and this column. So 9 sevens are 63, minus 3 minus 11 minus 33, 6 plus 1 is 6. The first row, first column done. Now second row, first column. 6 sevens are 42, minus 22, minus 2. Minus 2 into 1, minus 2, minus 2 into 11, minus 22. Minus 21, and then 77, and then this is minus 2, and this is your XYZ. Now 1 by 18, I simplify this part and write there. So 63 minus 33 is 30. 30 plus 6 is 36. Better. At least I can say that this is reducible by 2. Now 42 minus 22 is 20. 20 minus 2 is 18. I think these two values I am getting correct. Now 77 minus 21 is 56. And 56 minus 2 is 54. I am very close to getting the correct answer because it's all correct. Now if you divide each element by 18, so this will become 2, 1 and 3, and there you have comparison. X is 2, X is 2, Y is 1 and Z is 3. So you have got the answer, and here I conclude everything in this video. And now in the next video we'll do something more interesting and solve some beautiful questions of the matrices with some different kind of variables like the logarithmics or the binomial expansions or coefficients or better trigonometry. Thank you very much. Just subscribe to our channel and keep growing.